Okay, Assalamualaikum and hi everyone. Alright, today I would like to discuss about tutorial 7.3 ABC. Okay, it's about solubility equilibrium that focus on the definition of solubility, okay, molar solubility and solubility product. So these three definition you should remember, and then calculate KSP from concentration of ion and vice versa, and then predict possibility of precipitation of slightly soluble ionic compound by comparing the ionic product QSP to KSP. Alright, so the first question 1A, define solubility. For this question, you can refer to your lecture note. Okay, so solubility can be defined as the mass of solute that dissolve in a given quantity of solvent, okay, to form a saturated solution, and the unit here is gram per liter. Okay, second question, the solubility of silver sulfate is 1.5 times 10 power negative 2 mol per liter. Calculate the solubility product of the salt. Alright, so referring to the unit here, so the value of 1.5 times 10 power negative 2 is referred to the molar solubility. Okay, and then the question asks to calculate the solubility product, which means the value of KSP. Okay, what should you do? First of all, you have to write the dissociation equation for the salt that is equal to the silver sulfate. Okay, silver sulfate exists in solid and it is slightly soluble salt, so you have to use reversible arrow, and it will form into aqueous ion. So remember, your equation should be balanced. Alright, so next second step, you have to draw the ice table. Alright, so here is the ice table. Okay, so since lightly soluble salt here is in solid, so therefore in the ice table, you can just write there. As the aqueous ion, alright, for the initial is 0 because not formed yet. Change in concentration, so you have to refer to the coefficient. Okay, because the coefficient here for silver ion is 2. So, the change in concentration, it will increase positive 2x. As for the sulfate is coefficient 1, so increase positive x. Okay, so at equilibrium, so 2x for Ag plus and x for SO4 2 minus ion. Okay, for the next step, in the question is already given here is referred to the molar solubility. So molar solubility here is referred to the value of x. So therefore from here we can calculate the concentration of silver ion at equilibrium. So 2x, which means 2 times 1.5 times 10 power of negative 2 molar. So we get here 3 times 10 power of negative 2 molar. Okay, and then do the same step to calculate for the sulfate ion at equilibrium, that is referred to x, that is 1.5. Okay, the next step, you can write the KSP expression. Okay, so remember the coefficient now become power of. Okay, and then substitute the concentration. And finally, you will get the value of KSP here is 1.35 times 10 power of negative 5. No unit, Remember, no unit. It was found experimentally that the KSP of calcium sulfate is 2.4 times 10 power negative 4. Calculate the molar solubility of calcium sulfate. So what should we do? So first of all, so you have to write the assumption. Okay, so sample assumption here, let X is equals to the molar solubility of calcium sulfate. So here is the first step. Okay, second step, write the salt dissociation equation. Okay, so calcium sulfate exists in solid and it is slightly soluble salt. So use reversible arrow and it will produce aqueous ion. Alright, so now draw the ice table like this. Because the salt is in solid, so just write dash, dash, dash. So initial concentration for the aqueous ion is 0 because not formed yet. Okay, and then for the change in concentration, both ion have 1 mole. So therefore, it will increase positive X, positive X. So equilibrium concentration for the ion is X and X. Next step, what should we do? So we write the KSP expression. Okay, and then substitute the value of X. X here is referred to the concentration of both ion at equilibrium and also the value of KSP. Okay, next, find out the value of X. So, suppose you get here 1.55 times 10 power negative 2 molar. Okay, so X here is equal to the molar solubility, so we can write. So, therefore, so we move to the next step, number 3. Okay, so will precipitate form if 0.2, if 200 ml or 0.004 molar BaCl2 is added to 600 ml 0.008 molar K2SO4 and given to you the KSP value. Okay, so when we illustrate in form of diagram, so meaning that in the beaker it contains 600 ml 0.008 molar potassium sulfate. Okay, and then the solution added into the potassium sulfate solution is barium chloride, 200 ml 0.004 molar barium chloride. Question asked about, is there any precipitate form? But what is the precipitate? So that is what we want to discover. Okay, so write the equation. Potassium sulfate and barium chloride, it will produce two products, that is potassium chloride and also barium sulfate. Okay, between these two salts, so we already know that in the previous lesson, for the alkaline metal ion that is under chloride salt, usually it is soluble. So this is soluble salt, like NaCl. So therefore, it does not have any KSP value. However, for the sulfate salt, especially for the barium ion, okay, barium sulfate, so this is slightly soluble salt. So that's why we want to find out whether barium sulfate can form precipitate or not. So because of that, we want to calculate the QSP and compare it with KSP value. Alright, so first of all, what should we do? Write the salt dissociation equation for barium sulfate. Make sure your equation is balanced. So it is already balanced here. Alright, so next step, actually the QSP is referred to the concentration of Ba2 plus times concentration of SO4 2 minus. Okay, so because of that, we have to calculate what is the concentration of barium 2 plus ion and sulfate ion. Okay, so calculate the initial concentration, not initial here. Okay, by using all the data given here. Okay, we start with concentration of barium 2 plus. Okay, so first we have to calculate the mole of Ba 2 plus ion present in the barium chloride solution. So molarity times with volume. So molarity given here is 0.004. Okay, times volume 0.2 convert into liter. So from here we will get the answer here. Okay, now we calculate for the molarity. So molarity meaning that we have to calculate the volume. Okay, volume total. So we have 200 ml plus 600 ml. So we get here 800 for the total volume. Convert into liter, 0.8 liter. Alright, so now we can calculate the concentration for barium 2 plus ion. So mole over volume total. So mole is 8 times 10 power of negative 4 mole. And for the V total is 0.8 liter. And from here, the concentration of barium 2 plus is 1 times 10 power of negative 3 molar. Okay, next we calculate the mole for sulfate ion that is come from the potassium sulfate. Okay, potassium sulfate here. So molarity times with the volume. So molarity given here is 0.08. Alright, and the volume here is 600, 0.6 liter. So from here, we'll get here 4.8 times 10 power of negative 3 mole. Okay, next step, calculate the concentration of sulfate ion. Okay, mole over volume total. So mole here is 4.8. Okay, next step, write the QSP expression. Alright, so just the same like KSP. Okay, next, substitute the value of the concentration. So from here, we will get the answer is 6. 10 power of negative 6. Right, so the next step, we compare QSP with KSP. Negative 10, So therefore, QSP value is bigger than KSP. So therefore, the value of QSP indicates that the concentration of the ion are too large, which means the concentration of both ions here is very large. So therefore, we get the value of QSP is very high, larger than KSP. So therefore, the solution here is super saturated, since it contains more aqueous ion. Okay, so because of that, according to the Le-Chatelier principle, so the system will shift to the left. Okay, in order to consume the excess of aqueous ion here. So therefore, some of the barium sulfate will be formed, will be precipitated out. Alright, so that is all for 7.3 A, B, C. Alright, so we continue our tutorial. So now is tutorial 7.3 DE. That is more focused to the common ion. So first you have to know the definition of common ion effect. And then you must also able to perform calculation relate to the common ion effect. So the first question here, number 1. So define common ion effect. Alright, so here is the sample answer. Okay. Alright, so we can define the common ion effect as the reduction. Okay, reduction in solubility of salt in the presence of common ion. Common ion mean common the same ion that present in a mixture of the slightly soluble salt, and therefore this ion will decrease the solubility of the salt. Right, so for the second question, right? So calculate the molar solubility of silver chromate, okay? So in pure water and also in 0.005 molar potassium dichromate solution. And given to you the KSP value, okay? In the question actually, we have to explain, okay? Must include the explanation, this one. Alright, so now we move to question number 2A. Alright, so first of all, what should we do? So we have to write the salt dissociation equation. Second step, draw the ice table. Alright, so next step, we substitute all the values. So right, since the salt here is in solid, So just write dash, dash, dash. Okay, as for the initial concentration for the aqueous ion is 0 because not formed yet. Change in concentration refer to the coefficient. For Ag coefficient here is 2, so increase positive to x. Okay, as for the chromate ion, increase positive x. Okay, and then at equilibrium, this is 2x and this is x. Right, so before I forget, so you have to write the assumption. Let x is equals to the molar solubility of silver chromate. So you have to write this assumption, then write the equation and also the ice table. Alright, next, what should we do? So write the KSP expression. Okay, and then substitute KSP value and the value of the concentration of Ag plus according to the ice table. This is 2x squared. Concentration of chromate is x. Okay, so from here you will get 4x cubed equals to 9 times 10 power of negative 12. So find out the value of x. So when you calculate, suppose you get 1.31 times 10 power of negative 4 molar. Okay, so therefore, the molar solubility of silver chromate in pure water is alright. Next, for B question us here to calculate the molar solubility of silver chromate in solution of 0.005 molar potassium chromate, and then you have to explain. Alright, so same step. First of all, you have to write the dissociation equation for the salt. Okay, don't forget to write assumption. Okay, next, draw the ice table. Alright, so here is the ice table. Next, substitute all the values. So for the salt is in solid, so just write dash, dash, dash. So initial concentration for Ag plus is 0 because not formed yet. Okay, as for the chromate, it has value because there is a common ion present that is referred to the chromate ion that came from the potassium chromate. So the initial concentration for chromate ion is 0.005. Okay, as for the change in concentration for Ag plus, refer to the coefficient here. So it will increase positive 2s. Okay, chromate here is 1, so increase positive s. So at equilibrium, so for the Ag plus, 0 plus 2s equal to 2s. Okay, for the chromate ion, 0.005 plus s. Okay, next step, what should we do? So we write the KSP expression. Okay, and then substitute the concentration at equilibrium. Alright, so and then we can assume that S is very small. Okay, so therefore 0.005 plus S is approximately to 0.005. Substitute value of KSP. Okay, so we want to find out the value of S. So when you calculate, suppose you will get 2.12 times 10 power of negative 5 molar. And then write the conclusion. So therefore, okay, so here is the conclusion. Alright, so next, how that we can explain here. Alright, so here is the sample answer that you can include in your explanation. So before that, you have to compare the molar solubility of silver chromate in potassium chromate, alright, with solubility of silver chromate in water. Okay, the solubility of silver chromate in potassium chromate solution is lower than in the pure water. So this is the first mark. Okay, next point. So give reason why become lower because of the presence of common ion, that is chromate ion, and that exists in potassium chromate solution. And because of that, the concentration of chromate ion will increase. So in order to reduce the concentration of chromate ion, system shift to the left. So therefore more silver chromate will precipitate out, and therefore the solubility of silver chromate in potassium chromate will decrease. Okay, so that's all for today. Thank you and Assalamualaikum.